All right, let's talk GKE. Today we're going to move way beyond just the default click, next, finish kind of Kubernetes setup. We're diving into how to build a GKE compute architecture that is truly strategic. One that's designed from the get-go for amazing performance, solid reliability, and of course, cost efficiency.
And this really gets to the heart of the matter for pretty much anyone working in the cloud, right? How do we find that sweet spot, that perfect balance between giving our apps all the power they need, making sure they are rock solid and never go down, all while keeping that monthly bill from giving us a heart attack? It's a real balancing act.
So here's our game plan for this explainer. We're going to start with the absolute foundation, node pools. Then we'll layer on some intelligence with autoscalers. And after that, I'll show you a secret weapon for saving some serious cash. We'll tie it all together with a real-world example and then wrap up with some key design rules you can start using right away.
Okay, first up, node pools. You got to think of these as the fundamental starting point for organizing your cluster. This isn't just a feature. It's where smart design really begins.
So, what in the world is a node pool? Well, it's actually super simple. It's just a bunch of your worker nodes inside your cluster that all share the exact same DNA. We're talking the same machine type, the same amount of disk space, the same OS. They're basically identical twins.
Now, here's why this is such a big deal. I mean, you could just throw everything into one big generic pool, right? Sure. But separating your workloads into different specialized pools means you stop wasting money. You don't have to run your simple little web server on a super expensive high CPU machine just because some other data job needs all that muscle.
And this slide just lays it out perfectly. Think of your node pools like specialized teams on a sports roster. You've got your general-purpose all-rounders that can handle most of your day-to-day web traffic. Then you bring in the CPU-optimized muscle for the really heavy lifting, like batch processing. And of course, you've got the memory-optimized brains for things like in-memory databases. It just makes sense, right? You match the hardware to the job.
Okay, so we've sorted our workloads into the right teams. That's a huge step. But what happens when demand goes through the roof or suddenly disappears? That's where we build on top of our foundation with some real intelligence.
And this is where the cluster autoscaler makes its grand entrance. Its job is simple, but it is incredibly powerful. It just sits there and watches your cluster. If it sees pods that can't get scheduled because you're out of room, it automatically adds more nodes to the right pool. And, just as important, when things get quiet, it removes them so you're not paying for idle machines. The whole process is just beautifully logical. So picture this. Kubernetes tries to place a pod, but there's no room at the inn. That pod gets stuck in a pending state. The cluster autoscaler sees this little cry for help and wakes up. It double-checks your node pool rules to make sure it's allowed to add a new node, and if the coast is clear, poof, a brand new identical node joins the pool. Problem solved, and you didn't have to lift a finger.
Now, here's a crucial point. For ultimate efficiency, you want to pair this with pod autoscaling. The perfect flow is to first scale your application by adding more pods. You only want the cluster autoscaler to kick in and add more infrastructure when you've run out of room for those pods. It's this two-layer approach that really unlocks peak efficiency.
All right, you ready for the pro tip? Once you've got your cluster organized and your scaling automated, you can bring in the secret weapon for some serious cost optimization. Let's talk about preemptible nodes, which you'll also hear called spot VMs. The deal is, these are basically compute instances running on Google's spare capacity. Because of that, they're offered at a massive discount. Now, what's the catch? The catch is that Google can take them back with very little notice. This makes them absolutely perfect, but only for workloads that can handle being interrupted and starting over.
And when I say massive discount, I'm not kidding. We are talking about potential cost savings of up to 80%. 80 compared to standard machines. When you start using these for big batch jobs or data analysis, the savings can be absolutely astronomical.
But, and you have to hear me on this, you have got to use them for the right job. They are amazing for batch processing, rendering, anything fault-tolerant that doesn't care if it gets interrupted. They are a terrible idea for your main customer website, your critical database, or anything that absolutely, positively has to be available all the time.
All right, we've gone through the pieces one by one: node pools, autoscaling, and preemptible nodes. So now let's see how this all clicks together in a real practical scenario.
So here's the setup, and it's a super common one. We've got a team that's juggling two very different kinds of work. First, they have their main web application. It's critical, it's user-facing, it has to be fast and reliable, period. And then they have a bunch of heavy data processing jobs chugging away in the background. These need a ton of CPU, but it's not the end of the world if they take a little longer.
And here it is, the elegant solution. This is that aha moment. They create two completely separate node pools. For that critical web service, they use a general-purpose pool running on reliable, standard nodes. No surprises. For the background jobs, they spin up a CPU-optimized node pool using those super cheap preemptible nodes. The result? They've perfectly matched the infrastructure to the workload, guaranteeing rock-solid reliability where they need it and slashing costs where they can afford to.
So let's wrap this all up. Let's distill everything we've talked about into a clear blueprint, a set of recommendations you can use to design your own smarter GKE clusters.
Recommendation number 1, isolate your workloads. Seriously, using different node pools for different kinds of applications is the foundation of everything. It stops them from fighting over resources and makes sure you're not paying for power you don't need.
Second, and this is a game changer, automate your scaling. Just let the cluster autoscaler do the work. Let it handle the spikes, let it handle the lulls. It frees up your team to do more important things than manually adding and removing nodes.
And our final recommendation, number 3, use preemptible nodes, but use them wisely. Go find those fault-tolerant, non-critical jobs in your system. They are a gold mine for cost savings. But like we said, you have to be smart about where you use them.
You know, when you boil it all down, what we've talked about today is really a shift in thinking. It's about moving away from just trying to get your containers to run and moving toward intentionally architecting a system that's efficient, resilient, and cost-effective from its very DNA.
And that leaves us with one last question for you to think about when you look at your own environments. Is your GKE architecture something that just happened by default? Or is it something you've truly built by design?